So I'm going to show off how I overclocked my 9900K or 9th gen CPU. So to get started, we do actually need a few programs. Use Blender. I do recommend getting the latest Blender from the beta. There's quite a different bunch of programs you can use for stress testing, but we're going to use Blender just because it's real and it's non-synthetic and it's still intensive enough to actually stress your system. So just download Blender, just the beta build. It comes in a zip, so you can just quickly unzip it, and then download the Blender BMW demo files. It'll be right here. It's actually one of the more intensive ones, just because I guess there's a lot of geometry and whatnot going on in some of these other ones, and they don't pull the same amount of power. And then besides that, you need a hardware info. Hardware info is really quite good at recording statistics and whatnot. So we'll just open that up, and I'll get my Blender, which is over here. So all you need to do is open up your Blender, open up the BMW wherever you extracted it, CPU test, come over here to the right where it says output, dimensions, and there should be a save profile for 4K UHD TV, 2160p, and that's the 4K resolution. And if you just hit F12, it should start encoding. Now, this is a really good test because obviously it's quite intensive and it's actually realistic. So compared to some of these other ones like Blender and whatnot, they will pull way too much power and they will just pretty much crash your CPU no matter what. Now we're just going to go over to hardware info, which is incredibly useful for monitoring because it has a bunch of statistics and whatnot. It will tell you if you're thermal throttling and a bunch of useful information that you can use to diagnose problems. But I do want to show you the most important ones. So number one is your vCore. So I set it to 1.2 for 4.7 gigahertz, and it's holding pretty good at 1.2, overshooting a tiny bit. But a lot of people get confused and they read VID. This is not your vCore. This is what the CPU is requesting. And it's very important not to get these confused because this is simply just requesting voltage. This is not what your CPU is actually receiving. So you can see in the BIOS I've set my voltage to be 1.2 and the vCore is showing me what I'm actually getting sent to my CPU. So don't read VID. You can even disable SVID support in your BIOS, and I would kind of recommend doing that just because it's going to be inaccurate if you're manually setting your voltage. So you can see it's 4.7 gigahertz and it's stable, and you can see it's using all my cores and whatnot. And another very useful reading is the power usage. So this is very useful just for seeing how much power you're pulling, because if you're not pulling a good amount of power, which is 140 for 4.7 gigahertz and 1.2 is about right. I am underwater, so I'm SpongeBob, so it's a little bit less. Temperature can play a part in how hot or how much power your CPU pulls. So the thing is, if it's only pulling like 90 watts or maybe even 140, it's a bit deceptive right now, but if it's not pulling enough power for the stress test, it could be because you're limited by amps. In the BIOS, there should be a current limit, and you need to pretty much raise that to as high as it will go, which is pretty much 255.75, but 250 amps, and you can see I'm not pulling anywhere near to 250 amps. The default is much lower. So besides that, we can see the CPU temperatures, and we can see if we're not thermal throttling and whatnot, and it's just a really good test. So what you need to do is pretty much just set your voltage to manual and just start at 1.2. I'll show you all the different results I've gotten. I've actually made pretty pictures so we can look at them a little bit better. So these are the results I've gotten with air. It was a Thermal Right True Spirit 140 power with 2 Noctua fans, and these are the voltages and the frequencies I received while using this cooler at full RPM. And I am 100% cheating by using full RPM because it's completely annoying and there's no way I would actually use that. And the problem is, as the temperature increases, you need more voltage. So if I were to use these voltages and frequencies and then turn down the RPM, it would probably go over 70 degrees and it would cause my CPU to crash. I do write AIO air and AIO here because AIOs aren't really that much better than air. They are a little bit, like 5 degrees or so you'll find, but they're kind of similar. So these are the results I've gotten with air, and you can kind of, you can judge by yourself. This is without AVX offset, so these are pretty good starting points to figure out. Obviously every CPU and motherboard is different, so if you were trying to target this one, for example, I would maybe start with a higher voltage, like 1.15 or 1.17, just because full RPM fans are just very annoying and probably not realistic at all. But I do want to show you, I recently got a water cooler, a custom AIO, or custom loop, and the results are quite a bit bigger. So with the lower temps, I was able to lower the voltage and lower the temperature and the power draw. even at the same voltage, it was drawing less power just because the CPU was cooler, and that's kind of a cool benefit. It's all these things stacked together, and it really makes a massive difference. So I actually got just a one-to-one comparison. Hold on, we'll just look at this one first. I'm making a mess of all my results. So you can see with my air cooling at 1.28 volts to reach 5 gigahertz, it was reaching 94 degrees, and it was pulling 182 watts. This is with Blender, and I put this loud bracket thing here because it was max RPMs. It was very loud. But with the custom water at the same voltage, I was pulling less power, and it is dead silent. Like, my fans and RPMs of the pump are just, they're set so low that I can't hear them when they're underneath my desk where my PC stays. And there's pretty much no point of making any of the RPM or anything faster because it lowers it by a few degrees, but it's a massive difference. But not only is it colder, I can lower the voltage because of the heat reduction, and it means that I get an even bigger jump in temperature. So if we look at the custom water loop, and we compare it, I don't have a big enough monitor. And we compare them, you can see it's quite a big difference in terms of in terms of like temperatures and power draw. You can see like I'm pretty much maxed. If my TDP is if my TJ max is 100 degrees, you can see I'm pretty much stuck at 5 gigahertz if I'm not using an AVX offset. But with my water results, I can I can definitely keep going, and my temperatures would still be perfectly fine. I do want to say this test that I just came up with, there's no reason why I use specifically 4K or whatnot. It takes roughly 40 minutes, and these are just the 40-minute results. So if I would just keep lowering the voltage, and I'll just show you that I did put quite a bit of time into getting these results. So it's not like I tried many different things, and I've recorded a bunch of different VRM temperatures and whatnot, and different tests that I used. And this probably Blender BMW was just my favorite because it wasn't insane, and some of the Prime results were very weird. I don't really recommend using Prime 95. It was very weird, and the results didn't really make sense sometimes. So Blender, it's great, but it takes roughly 45 minutes to finish this test, and it's definitely not completely stable. So you can see I'm using 1.2 volts, and that's just, it's overkill, but I just wanted to get a flat baseline for the LLC, so I can see if I'm drooping or not, and I'm not. But I've tried to run like this one for a bit, and I did crash. And that's just because I assume it's just because I'm on the very edge, and you know my fans were at max. So even if you do get a result and you don't crash after 45 minutes, maybe you might want to up it. If you don't really care, you can just keep running it, and then if your computer crashes, just up it by 5 millivolts or 10 millivolts. But yeah, you might need to up it by 10 or 5 millivolts just to make sure that you're stable and pretty much no matter what. And it would be really stupid things, like I'd be browsing YouTube and then it would crash. But if I just up it at like 5 or 10, it's fine. And another thing to watch out for is when you're testing is to make sure that you keep an eye on... so if anything crashes, that's probably a bad sign. You're probably unstable. But Hardware Info has this very cool Windows hardware errors. Okay, so these hardware errors are the errors that your computer Windows detects. So even if this doesn't increase and let's say Blender crashes, there's a good chance that Blender crashed because Windows had an error because you're unstable and it couldn't fix it. So these only account for the ones that your computer doesn't, or your computer does recognize. So if you get any of these, that's a bad sign. If your computer crashes, or if an application crashes, that's a bad sign, and it probably means you're unstable. So yeah, pretty much that's everything you would probably need to know. One thing to consider is if you're unaware, it's a very important thing that not too many people talk about, but it's the load line calibration. It's very useful to have an application that you can change your settings live, but it can cause your system to crash randomly if you do hit apply. But your LLC is load line calibration, and it's how much compensation your voltage... So your computer will naturally, or your motherboard will naturally droop with load, and it's completely normal. So if you apply 1.2 volts and you put it under load, there's a good chance it will go down to like maybe 1.1. Like it'll just droop down when you put it under load, and that's completely natural. And load line calibration will try to compensate this and apply more voltage to prevent this droop. Every motherboard is different. You're gonna have to look it up. It's very important. It's a very useful setting. Make sure you set it. I'm gonna try turning it. I'm gonna turn it up. You can see now it's overcompensating. So I don't want to keep playing with it because it might crash. But yeah, you could tell that maybe if I was on level 1 or default, it probably would droop so far down that I would probably crash. But I don't want to mess with it now, just because it can cause your system to crash just playing with this in the Windows. It's best to do it in your BIOS, but it's very useful for just quickly testing and quickly adjusting your settings after you found a stable setting. Just quickly changing the voltage a little bit lower and retesting. But this is pretty much all you need. I hope that's useful. I hope you gain some knowledge from that, and have a good one.